Hello, Year 10s. How's it going, everybody? I can see that you guys are already on. Did you see that I made the mistake on the time? I put PM instead of AM or something, and it was like, you'll begin your thing in 24 hours. I was like, what? Oh, dearie me. Right, let's do the register, folks. Doing well already, which is lovely. Hello, Year 10s. How's it going, everybody? Yeah, sound seems to be okay. Right, I've got Rue. Do I have Harris? Got no Harris yet. Do I have Nick? Where's Nick? Yo, Nick. No, Nick. Hey, Nick. Ashley? Where is everybody today? Shanley. Yay. Hi, Shanley. Anna. I think I saw Anna. Hi, Anna. Kieran. Is Kieran in the house? There's Harris and there's Kieran. Ooh. Harris just strolls in late. Kieran strolls in late. Missing Nick and Ashley. Do I have Yura? Does anyone know if Yura's watching? There's Nick. Yo, Nick. Still missing Ashley. Does anyone know if Yura's watching? Here, I'm here. What? Lovely. Toby. Do I have Toby? Is Toby in the house? Haven't seen Toby yet. Be patient. His thing is super laggy. Okay. Somebody let me know whether or not Yura's here. That'd be grand. Yura is watching. Thanks to you, Wen. You're such a star. Do I have Toby? Ashley, and still not here yet. There's Toby. There's Ruby. Love it. Toby's in the house. Ben. I've seen Ben. Seen Tong, seen Andy, seen Vic, seen Isabel. Seen Ruby. Moses? Have I seen Moses? I think I have seen Moses. Yeah, I saw Moses. Moses and Con and Wen. Amazing, everyone's here. Winner, look at that. Everyone except Ashley. Where's Ashley? Come on, Ashley. Come on. Where are you, eh? Okay, our marker is missing. Marker is missing, and then she can just rock in late. Okay, folks. Just come out of a year 7 lesson, and it was like straight into a year 10 lesson. It's just like, struggling today. Moses, love that. Very laggy on the chat today. Right, Ashley's still not here. Amazing. I'll close down the register. Don't need that anymore. Keep the chat up. Amazing. Right, guys. Acid base lesson 3. Amazing. Let's share screen. Got to keep an eye out for Ashley. Ashley's never late. Why is Ashley late? It's very upsetting. Okay, right. We're on. Right, guys. Title and learning objectives. Now, I do know that in previous lessons, we talked about proton donors and acceptors already. So I'm hoping that I'm going to be able to add to these learning objectives, because I feel like we're going to tick these off pretty quick, which will be nice. And do you know what? You do have a homework this evening. However, the homework, it caused a bit of trouble. It caused a bit of trouble with my other year 10s because it took them quite a long time. And so what I'm thinking of doing, I've got you guys today, Thursday and Friday. I think what I'm going to do is I'm going to set you it on Thursday. No, hang on. Maybe I'll set you it today for Friday. Would that be better? I need a bit of feedback on the chat if we can. That'd be great. Okay, so 3 learning objectives. Number 1, no Bronsted and Lowry theory. So we've got to talk about, and I don't think we've already done that, have we? Yeah, we didn't talk about Bronsted and Lowry. No, we haven't mentioned their names yet, but we will. We will do that today. Talk about proton donors and acceptors. This is their concept. And then also we're going to identify acids and bases from equations. Being able to understand. I'm glad that Toby said yes, fab. I'll set it to you for Friday. At least that gives you a couple of days to do it. Could you set it tomorrow? Ruby, does it matter if I set it today or not? You just do it tomorrow. I'm here. Oh, Ashley rocking up late. Hi, Ashley. Ugh, turning up late. Okay, so let's move. Let's crack on. I'll have a think about the homework. As I said, I'll just set it for Friday, so then you got 2 days to do it. Yeah. So okay, Bronsted and Lowry. We've already spoken so far. We just quickly do a quick recap. Yeah. Key things that we have picked up so far. Number 1, H plus is acid. Yeah, that's what makes an acid an acid. And we spoke about how H plus is a proton. Yeah, we spoke about that. It's the idea that the hydrogen atom has lost its electron and therefore is just a proton. We then said that OH minus is base, yeah, or alkali. You can use either word really in that setting. And of course, what we're then realizing is if H plus, so what we now realize, you can't really do that. We know that the OH minus isn't a proton, it's something else. But the key thing here, so this is what we kind of first did. Then our third fact, I'm very aware that I just want to do a recap because I haven't seen you in like 5 days. And it is tricky this. I do 3 days in a row and then don't see you. So we've said H plus is acid, OH minus is base. What we've then also said is that strong acid, yeah, or base, it doesn't really matter. Strong acid or base. The word strong, I'm going to get rid of that. Yeah, the word strong now means fully ionized in water or dissociated, whichever one you want. Yeah, fully ionized in water. And then we got weak. This is what we've done so far. It's just a recap. Weak is partially ionized in water or dissociated, whichever one you prefer. Doesn't matter. Now, can I just say, by the way, the internet is a great source of chemistry, but there isn't some junk that's there. Just to let you know, one of the things that I saw happen last year was that my year 10s last year picked up something that I had not taught them. Some of them wrote down not fully ionized in water. Some people put that. This is not okay. Let me know. I'll explain why. Some students really argued with me over this. They were like, but not fully is the same as partially. And I'm like, no, it's not. The reason being is not fully could mean not at all. Yeah, it's not full. Well, hang on a minute. If I had an empty glass and I said, is it full? You say, no, it's not full. You would say it's empty. Yeah, but you could say it's not full as well. You can't say not fully. You must say the word partially. So I don't know where they got it from, which website gave it to them, but it was wrong. And I was like, you need to be super careful. Okay, next. So that was basically our recap. We also did other things. We also did we do indicators? Did we talk about the pH scale? Just quickly check. Yeah, we spoke about the pH scale. We spoke about numbers. We even did the ionic equation for neutralization. So exciting. Yeah, so we also did neutralization. Neutralization, yeah, is this idea of an acid reacts with base. Yeah, acid reacts with base. And we got this ionic version. Yeah, I've just put them so far apart, I don't know why. Yeah, H plus OH minus goes to water. So we picked up, this is the very first example of an ionic equation. No, you guys got some in redox, in electrolysis. Yeah, but this is called an ionic equation. It's what's doing what. Yeah, it's what actually is happening. So we picked up that as well. And we also picked up indicators. Yeah, so we've also picked up that fact there are many indicators to know. We need to know litmus. Yeah, we need to know universal indicator. We need to know phenolphthalein, PHTHAEIN. There you go. Phenolphthalein. and also methyl orange. These are all your indicators at GCSE. Orange. It's French for orange, if you're wondering. Methyl orange. So we've done our indicators. I mean, you need to know your colors. Yeah. Know your colors. Yeah, gotta know it. Gotta know it. Okay, so today's lesson, we're now talking about the king and, annoyingly, the king and king. Our first title is Bronsted Lowry acid-base theory. Okay, so this is where I get all the names wrong. Thomas Lowry and Johann Bronsted. Johannes Bronsted? Johannes Bronsted? Yeah. But these are two guys. Yeah. And these two guys are officially the kings and kings, the king and king of acid-base theory. Yeah, I'm just gonna see if I can give him a crown over here. Need to make my pen thicker, definitely. Yeah, they are the king and king of acid-base theory. Yeah, and these guys worked together to prove a theory that was nearly 100 years old. And the original theory comes from Arrhenius, but these guys were the one that proved it. They won the Nobel Prize as a consequence, by the way. Won $1 million for this theory. And what these guys said, and they're very clear. So a Bronsted Lowry acid is a proton donor. Yeah, so HCl is an acid because what it will do is it will give its proton to somebody else. Yeah, it will hand over it's going to donate a proton. Yeah. So for example, if I did the reaction between NaOH, you realize that this is where it becomes kind of A-level, really. Spectator ions are the Cl and Nas. They don't do anything. What the HCl is doing is it's handing over, yeah, the HCl is handing over its proton to the OH minus. Yeah, it's giving it over to it. Hence why you get water. Yeah. And then salt, of course, as a byproduct. So they said that an acid is a proton donor, somebody that donates the proton to somebody else. So what did they then say for the base? Well, we know this already. So a Bl base, I'll underline that. A Bl base is a proton acceptor. Yeah, somebody that's going to accept a proton. So for example, if I go HCl and I react it with X, if X takes it, yeah, then that was acting as the base. What's happened is, this is the donor, yeah? It's going to give its hydrogen ion to the X, yeah? And the base is the acceptor. It's just going to take it. And this is what I mean by recognizing them from equations. So we've covered Bronsted-Lowry, these two guys who describe these things, and then we've got their definitions. Yeah, they just talk about protons and proton transfer. The idea that protons can be swapped around. Okay, so this is where we got to. So the next thing is we need to apply it to equations. Let's have a look at some equations and see if we can figure out which one's the acid and which one's the base. Yeah? So if we do HCl plus, let's start off easy, plus NaOH, yeah, I'm going to get H2O and salt and water. Right. Everyone here would recognize that this one's acting as the acid, the proton donor, and this one is acting as the base because you know them as the proton acceptor. Everyone knows that because you know the people involved. Well, what would happen if I give you something you don't know? Let's try this. Let's try this. Let's go HX plus Y goes to HY plus X. Let's just do a general one, right? Who was the acid? Who was the base? Who is the donor? Who is the acceptor? You realize those sentences are the same. On the chat, please, quick as you can. I've only got 6 people watching. That does annoy me. I wonder how many people. I want everyone in the room. Let me check the register. I'm going to look at the register, and I want everyone to contribute on the chat because I feel like people aren't watching it, and I don't like it. I'm now down to 3 people watching. Has something gone wrong? Has something stopped? Thank you, Kieran. Thank you, Ben. 2 people watching. Toby, thank you. Ruby, thank you. Nick, thank you. Ashley, thank you. Moses, thank you, Nick. And all 14 people are back. Isn't that interesting? Wonder what's going on. Otherwise, great job. Thank you, guys. Okay, let's get harder. Question 2. So we can go acid and base. Okay, let's make you a little bit more uncomfortable. Let's make you more uncomfortable. Hang on. Let's give you people you don't recognize. Gotta be careful. Yeah, okay. I can. Right. Guys, on the chat, glitch. I know, my comment is lost up there. There is 17 watching, glitch 100. It said 3 before. I think it glitched. Illuminati or something must be. That's amazing. An Illuminati bed. That's brilliant. Guys, who's the acid? Who's the base, please? Who's the acid? Who's the base? Ah, Kieran. That's the point, isn't it? I love that. No, they're not both acids. Look at the equation. Yeah, somebody is gaining a proton and somebody is losing it. Who is the acid and who is the base? Well done, Rue. Good job. Both acids. Ruby, you're wrong. Aren't both acids? Is HNO3 the acid? Yes, it is. Well done, Tong. Yes. I guess phosphoric base, since it accepts. Correct, Kieran. Wait, no. Right. So, guys, the problem is, you see, it's very easy to become lured into chemistry and its rules. Yeah, but what you realize is, if you were to mix 2 acids together, what's going to happen is the one that's stronger is going to force the other one to act as a base. It will happen. Yet this can occur. I'll give you another example in a minute. So in this case, nitric acid here has this proton. And at the end, it's missing. Yeah, it has given that proton to the phosphoric acid. What that means is this acted as the proton donor. This was the acid. And the phosphoric acid has acted as a proton acceptor. And this is what I mean by making you guys feel a bit more uncomfortable. Yeah, but why? Because it can, Ashley. That's why. Confusion. No, don't be confused. Remember that each bit that I'm teaching you builds on the other bit. Yeah, I've told you guys already, learn your acids. Agreed? We know them. And they will act as an acid most of the time. That's why you learn them. But then every now and again, what they're going to do is they're going to give you something that is a little bit more complicated, which shows that if you put these two acids together, the nitric acid dominates and will force the phosphoric to accept. Yeah? So let's do another one. And the great thing is the question stands out a mile, Ruby. It's really explanation 101. It stands out a mile. Look at this one. This is another true equation. This does happen. Totally true. Who's acted as the acid and who's acted as the base? Who's lost, who's gained? That's all you need to do is track. This is like, do you know that game with the cups and the ball? And it's like, follow the ball, follow the ball, follow the ball, moving around, moving the cups, moving the cups, moving the cups, follow the ball. Which one is the ball under? We are just following the proton. Yeah, this is just follow the proton. Lol, follow the H+. What's going where? Yeah, so who's the acid, who's the base? Would the new solution be a stronger or weaker acid? Oh, blimey. Rue, that's a really good question. Ben, wrong way round. I love that. You realized immediately the other way round. That's brilliant. Nitric acid, nitric base, sulfuric acid. Well done. Spell done, Kieran. Good job, Ben. I know that you wrote it the other way around. Rue, your question's really difficult to answer. It's going to be it would be less acidic only because I know the reaction, Ben. Sorry, Rue. Because in reality, this is the hydrogen nitronium ion, which is going to decompose to give me the nitronium ion in a minute anyway. So it's only because I know the reaction. It would be less acidic. There is an acid-base reaction going on. It's a type of neutralization in reality. So what we know is we've got nitric acid had it here. Oh, nitric acid now has 2. It's gained 1. This guy gave it another proton. And look, that makes sense. This one had 2 and now it's got 1. So the sulfuric is acting as the acid. It's a proton donor. Yeah. And the nitric acid is acting as the base. Yeah, this one's the base because it's acting as a proton acceptor. It can be done. There we go. The what? So is the acid, that's correct. Yep, the nitric acid is the base. You saw nothing. So all this is just follow the proton. I'll give you one more, just for fun and games. Give you one more. Ooh, let's go really hard. Oh, think about it, Mr. Duncan. Think about it. Think about it. Oh, how hard do I want to make this? Holy mackerel. Blimey, that's complicated. That is very complicated. Right, guys. All right. So if they do give that plus that, what do we put? Ashley, they won't ever do that to you. Yeah? Oh, Ashley, I love that. I feel like it's just that question's like fear. Ashley, they won't do that. They're going to give you an equation and you have to figure out who gave it and who accepted it. That's it. They'll give you the equation. This is not expected for you to be able to build. To build these is A2, just so you know. Guys, who's the acid? Who's the base? Acid? Base? Who's the acid? Who's the base? Find the proton, and that's it. Just follow the proton. Find it, and it is the acid. Well, magnesium, the base, ammonium chloride is the acid. Is the acid. Well done, Toby. Well done, Rue. Well done, Kieran. Well done, Toby. Well done, Tong. Well done, Ruby. That's great. Well done. Which means if you've got the acid, the other guy must be the base. Well done. So this guy is the acid. Acid. Why? Because it had 4 of them. Yeah. And now it's only got 3. Shouldn't color it in like that. It's rubbish. Yeah. It had 4. It's now got 3. It's lost a proton. It's given it away. Yeah, that is a proton donor. Yeah, and therefore this must be the base, the proton acceptor. Now you're going to go, but magnesium's not accepting the proton. Well, you're right. That's why there's another theory later on called the Lewis theory of acids and bases, where you talk about electrons. But in this case, it's just nice to be able to do this. Yeah, it's great. We're there. You're understanding what I'm doing. I know this is hard, guys. I know. Being able to recognize, wait, Mr. Duncan, doesn't like the H plus go to like thin air? Well, yeah, it's becoming a gas. Oh, that's funny. It's become exact. It's coming because like the magnesium accepts the chloride. The problem is when I give you equations like this, I'm walking myself into more trouble. The magnesium, you realize that the proton is being lost by the ammonium ion. The proton gains the electrons from the magnesium. The magnesium would usually want to bind with it, but the hydrogen doesn't want to bind to the magnesium. It's going to become a hydrogen gas and leave. So the magnesium then forms an ionic bond with the chloride ion instead. But don't worry, that's not what I'm trying to explain. Oh, it's funny. Anyway, so I'm going to give you one more. I'm going nuts here, aren't I? I really shouldn't be doing these, but they are really good. Okay, last one, I promise. Last one. Vinegar plus. Let's make this tricky. I've got to think about that now. Okay, there we go, folks. Which one was the acid? Which one was the base? You can see what's going on. It doesn't. Once you see these questions appear over and over, you kind of go, oh, this actually isn't actually as hard as everyone makes it. Like it looks really complicated at the beginning, but actually you just kind of go, oh, hang on a minute, where's the proton gone? Where's he gone? And you can just track down who had it and who doesn't have it any longer. Yeah, it's not as complicated as it seems. I've now got 18 people watching. Am I meant to have 18 people watching? I don't know. Any ideas? Thank you very much. Rue's in there first again. Well done. Hey, there you go, Tong. Great job. Base, well done. Ben, yes. Shanley, yes, well done. Acid, Harris, well done. Wen, well done. Ashley, well done. That's a good job. So at the beginning, this guy had the H. At the end, it no longer has the H. The H has gone over this way. This is being the proton donor. And this one is the proton acceptor. So, base and an acid. Cool. I like it. So, great job. Guys, you know what you're doing. This is easy. That ticks off my last learning objective. How good's that? Right. Identify acids and bases from equations. Winner. Right. Going to add a learning objective. Let's do some salt next. Let's do some salt preps. Okay. New subtitle. Acid, base, reactions. Okay. I've still got 30 minutes. I want to just go through some acid-base reactions with you guys and then set you a homework to do some practice. Okay, so first things first. First things first. Rules. So, rule number one. You know these, folks. I know you do. Acid-base reactions rules. Metal. I need to shrink my writing. Metal plus acid goes to salt and hydrogen. MASH. We remember this. Yeah. Metal, acid, salt, hydrogen. MASH. Rule number one. Rule number two. Metal oxide. Metal oxide plus acid. Salt and water. Instead of getting hydrogen, we now get the water because the oxygen in the oxide is going to bind with the hydrogen. Number three. Metal hydroxide. There's oxygen here, folks. It's going to do the same thing. Plus acid, salt, and water. Great thing now. Learn those two together. Yeah, put them together. Last one. Metal carbonate. Metal carbonate plus acid, salt, water, and carbon dioxide. First set of rules. Got to learn those, guys. I cannot tell you how important those rules are for chemistry. Holy moly, are they important. So important. Rule one. Rule box one. Rule two. I don't want to rush you guys, to be fair. Yeah. I'll put it here. Second set of rules. Rules two. Rules one. Rules two. So, the next one is what salts are made from the acids. Yeah. We know that if we use the acid, it's going to directly impact the salt. Yeah. So if I use HCl, acid, AQ, I am going to make a chloride salt. If I use nitric acid, aqueous, I am going to form a nitrate salt. If I use sulfuric acid, I am going to form a sulfate salt. Yeah, second set of rules. I do want to mention other ones as well here at this point. Yeah, if I was to use, this is more A level, if I was to use phosphoric acid, I would make a phosphate salt. Yeah. If I use ethanoic acid, I will actually form an ethanoate salt, sodium ethanoate, salt. You notice the 8 on the end is the salt. Yeah, didn't we do this before? Yes, Kieran, we did. I'm just reinforcing. Kieran, how often do I redo things? All the time, because these rules matter. Yeah, these rules matter. Right, now, I've suddenly realized what I can do. There is 25 minutes left of this lesson. What I am now going to do is these rules are super important. And what I'm going to do is, I just want you guys to have a go at using these. I'm going to set you an exercise to do to finish off this lesson. Still got 25 minutes. This will be your homework to finish it, which means half the time will be already done, which is great. I'll set this. In fact, I'm going to go back to my lesson and go face. Guys, I have covered everything that I need to do on my lesson. What I'm now going to do is there's 25 minutes left of the lesson. I'm going to post onto the classroom, and I'm going to do it while you're here. I'm going to post onto the classroom your homework, and you can do your homework now. In 25 minutes, it will take you longer than 25 minutes to do, but it will certainly get you guys to kind of halfway through it, and then you can finish it off for Friday. I think that sounds very, very reasonable. Very reasonable indeed. Right. All I want you to do, by the way, they're going to ask you to convert words to symbols. Blimey. Right, download. Oh, is it already there? Ah, it's just disappeared. Just put it on the desktop. My laptop is having a small fit at me, which is really annoying. Right, I'll post that on the classroom now. Get back to the classroom. Classes, 10D. Right, classwork, create, assignment. You're going to have to practice going from words to symbol, folks, and balance. Don't forget. Yeah. Acid, base reactions. It's a big homework, so it's due for Friday. Do these. Do these. I will then go through the answers with you guys on Friday. It'll probably take up the whole lesson going through it. Add, file. Oh, it's hard work, this. Desktop, that one, go, upload. Right, guys, go onto the classroom, and it is there. Go. Guys, have a good rest of the afternoon. Enjoy the work. And I will see you guys tomorrow for more acid base. See you later.